The key to the hand soldering process is the person who does the job. There's a lot involved in making a good solder connection. It takes knowledge and practice to develop the correct hand soldering technique. It also takes knowledge and practice to properly maintain the soldering iron tip in good condition. Even the best hand soldering skills are not effective when using a damaged soldering iron tip. One of the major causes of unsatisfactory solder joints stems from defective soldering iron tips. How do these tips get damaged? Soldering iron tip care is one of the most important elements in giving any company an edge in the competitive electronics assembly industry. This is especially true when considering the negative impact lead-free solder alloys have on tip life. Let's face it, lead-free means reduced tip life and greater operating costs. Throughout this DVD, we'll be examining how we can reduce these costs. There are a number of factors that influence how long a soldering iron tip remains in good condition. For example, there is operator technique, the type and quality of the solder, the type of flux used, and the soldering application. In this video, we'll be discussing the causes of tip failure, and we'll provide guidelines on how you can increase soldering iron tip life. Extended tip life will result in more reliable solder connections and less expense for your company. With the average cost of soldering iron tips starting at around $10 and ending in excess of $100 per tip, you can see why it's important to keep tips in good condition. Soldering iron tip life has always been a difficult problem, but has been made worse by the transition to lead-free soldering. One of the biggest complaints about soldering with a lead-free alloy is the negative effect it has on tip life. This is primarily due to the high tin content found in lead-free solders. For example, eutectic solder contains 63% tin and 37% lead. In contrast, the tin-silver-copper solder common to lead-free hand soldering consists of 96.5% tin, 3% silver, and 0.5% copper. Tin is a very aggressive metal. At the 96.5% concentration, it will eventually eat through the plating on the tip of the soldering iron, reducing the life of the tip. That's because as the tin dissolves the plating, the tip becomes pitted and eventually cannot hold the solder. This phenomenon is similar to when a soldering iron tip becomes oxidized and will no longer hold the solder or transfer the necessary heat. To better understand the problem, let's look more closely at soldering iron tips. In general, soldering iron tips are similar in composition with the exception of the heating method or element. The tip is made of copper with a plating of iron. The sides of the tip usually have additional nickel plating followed by chrome. The chrome prevents solder from wicking up away from the working area of the tip. The soldering iron tip manufacturers then apply a coating of solder to the tip. There are many factors that will affect tip life, in particular, plating failure of the iron coating. The increased tin content of lead-free solders, along with the more aggressive nature of the lead-free fluxes, may cause a plating failure to occur more rapidly. Most tip manufacturers have now increased the iron plating thickness in the hope that this will prolong tip life with the more aggressive high tin content of the lead-free solders. Some people ask, why not plate it with really thick iron? The reason is that if the iron plating is too thick, the tip performance is degraded. In particular, this can affect the heat response time. In addition to the increased iron plating, the final solder coating of the tip is accomplished with lead-free solder. This tip will then be acceptable for use in either a tin lead process or a lead-free process. The tin in both the tin lead solder and the lead-free solder will form intermetallics with many other metals. This formation of tin intermetallics allows the solder to stick to the surface being soldered, which is referred to as wetting. This means that the tin in the solder is mixing with other metals, in particular the iron plating on the tip that protects the copper core. Every time the solder is wiped from the tip, it takes a little bit of the iron plating with it. Eventually, it will remove enough iron plating to expose the copper that is underneath it. Copper is a great heat source but is not very durable. Once the copper is exposed, the flux and tin from the solder corrodes it, creating holes or cracks. These holes and cracks can weaken the tip so much that the tip may just snap off. Now that you understand the tip life issue with lead-free solder, let's examine the other factors that are involved in tip damage and what we can do to minimize or avoid them. These factors include oxidation buildup, overuse of tip tinners, using the wrong temperature settings, excessive pressure, incorrect tip geometry, feeding solder into the tip, and mechanical damage. Let's start with oxidation buildup. Soldering iron tip oxidation occurs naturally when the iron is exposed to the air during the soldering process. If the tip is oxidized or contaminated, the solder will not stick to it. This is known as dewetting. Flux is used to clean the oxidation from the tip so that when solder is applied, it wets to the iron tip. When oxides form on a soldering iron tip, the tip performance is degraded. Oxides create a barrier that decreases the heat transfer from the tip to the connection. If the tip is not cleaned and tinned before putting the iron into the stand, the oxides can build up and render the tip unusable. The tip must then be scrapped or reconditioned. Tinning the tip is the best way to combat oxidation. The tinning process begins with the application of solder onto the working surface of the hot soldering iron tip. The solder coats the tip, forming a barrier that prevents oxygen from reacting with the tip. The flux in RMA cored solder improves this tinning process by breaking down any oxides already present on the tip and allowing oxides to float to the surface of the solder. Because of the reduced solids and lower activity of low residue flux cored solder, it is not as effective at tinning the tip as other types of flux cored solder. Since tips are now more prone to oxidation, proper tip maintenance is more important than ever. Proper tip maintenance involves one of two methods, either wiping the tip on a slightly damp sulfur-free sponge or dabbing it on a brass pad made specifically for hand soldering. After wiping the tip, always apply a fresh coating of solder to the tip before placing the iron in the holder. The way you store soldering irons when out of use is also important. You'll need to either turn the power off to the iron or to use a temperature control technology that will reduce the tip temperature while the iron is not actually being used for soldering. An example of this type of technology is the tip holder. Some tip holders will automatically drop the temperature to 300 degrees Fahrenheit or about 149 degrees Celsius, well below the melting temperature of solder. Remember that solder becomes liquid at about 220 degrees C for lead-free and 183 degrees C for tin lead. Specific types of tip holders are made by the soldering iron manufacturers for individual models of soldering irons. By turning the heat down automatically when you're not using the iron, the solder on the tip will solidify and will not eat away at the tip. Whenever a tip has a heavy oxide buildup, normal cleaning and tinning won't work. As we stated earlier, the tip will need to be scrapped or reconditioned. There are several methods of reconditioning an abused tip. One method is to utilize a tip scrubber. This method uses an abrasive material to remove oxides and any other buildup from the tip. Another method is to use a tip tinner, usually a mixture of solder alloy and flux, to recondition the tip. A less abrasive technique is to apply flux to the tip, then dip it into a molten solder pot. The best method of reconditioning the tip is to never let it degrade. Don't rely on frequent reconditioning to overcome poor maintenance habits. The surface of a tip is plated, and excessive use of reconditioning materials will degrade the plating and reduce the tip life. And never use sandpaper or an excessive amount of flux to remove the oxidation. This will remove the plating along with the oxidation. Now let's take a look at how excessive heat can cause degradation or damage to